This is my final project. First topic I wanted to look into were Taylor series, which are the infinite sum that can approximate a function from its derivatives. Has tons and tons of uses, such as in physics, they can be used to find approximations to messy equations. Some of the equations that they deal with, they can simplify them down into like a quadratic term. Also used in calculators, computers to calculate trigonometric functions as well as various integrals. An example, physicists, when modeling the motion of the pendulum, they can model sine of x to just really tiny changes of x as just x being the first term of sine of x Taylor series around 0. They can also use a Taylor series to make certain equations linear for certain bounds to find relations between other equations. Just a side note, I don't know much about physics or this advanced physics, so I don't know what many of the equations that I read about were, or a lot of the good uses that Taylor series are used for, but from what I saw, they're very important to physicists. Second topic I looked into were vectors. They can be used to represent multi-dimensional motion and location. And this has a lot of uses as well because we live in a 3D space world where 1D like equations don't particularly work. So it's got engineering applications like modeling heat conduction and forces in non-uniform flows. Engineers can use vector calculus to model fluid dynamics through a continuity equation, which takes in a vector field and then tells you at a singular point around it what the fluid is doing there. And I have, personal anecdote, I've used vectors in my free time when programming, where I would have a speed and say a car that's directions modeled by a vector. I can take that speed and use calculus to update the vector so it moves along correctly.